All right, let's do this. Welcome. Thank you guys for attending SQL Server Developer Tools codenamed Juneau and the Entity Framework, best friends forever. We're going to go through a bunch today, and we're going to leave about 10-15 minutes at the end for questions. Feel free to interrupt us with applause if you like something you see. And also, we encourage you to tweet at SQL SDT so we can see your feedback even during the session, once we're done. All right, so first I'd like to start with a show of hands. How many of you have been able to see SQL Server Developer Tools codenamed Juneau demoed at all before, either at the booth or previously? Nice, that's awesome. Okay. How many of you develop applications against databases? Good. How many of you own that database? Okay. How many of you, where you work, do your application developers and database developers always get along? Okay. Same person? Yeah. Okay, well, I hope you get along. Well, here's a scenario that might sound familiar to you. Adi here has been tasked with creating a very simple blog application. He needs to develop his application and his database, debug it, get it up and running against SQL Azure, all before his boss leaves work for happy hour at 6 p.m. So we have about an hour. Adi, do you think we can do this?
It's going to be pretty tight, but we'll see.
All right, we'll give it a try. I'm Sarah McDevitt. I'm a program manager on the Data Tools team in SQL Server.
My name is Adi Unathan. I'm a software developer on the Data Tools team.
And on the Data Tools team, we care about building applications, we care about building databases, and we care about how these worlds evolve and interact. So imagine in Visual Studio, you're developing an application with the Entity Framework, and you make a change in your entity data model, for example, add an author entity, and that change is immediately reflected down in your database schema. So an author's table is created for you. This integration is what we're going to be talking about today as a part of SQL Server Developer Tools codenamed Juneau. It's kind of a mouthful, so I'm going to call it SSDT. And as a whole, SSDT is your one-stop shop for SQL Server development. It's the most productive way to develop for SQL Server. It's a single suite. It includes what you've known as BIDs, so the analysis services, reporting, and integration services. A new piece, the database services, which we've been talking about a lot at the booth. I see some familiar faces here that I've talked to at the booth. And the database services includes an enhanced database project, new and enhanced tools, and it's efficient development for both SQL Server on-prem and SQL Azure. Finally, SSDT now has a deep integration with your .NET projects through the Entity Framework, and it's that piece that we'll be talking about today. That part is the most productive way to develop your applications and databases together. So I've already used a couple minutes of Adi's precious development time for his blog application. So let's get right into it. We are here in Visual Studio in Solution Explorer on the right. We have a simple console application loaded, just created brand new. So our first task is to add our entity data model to our project. And we're going to see how this is going to be able to allow us to build up our application and our database schema together. So as we add our EDMX, we have the options you're familiar with to seed your entity data model from an existing database. You can start with an empty model, of course. We have two new options with SSDT. So the first is to generate your entity data model from a database model. And we're going to go into this a lot more in depth later in the session, but this is referring to a new feature of SSDT database services, which is a SQLX snapshot. It's a single file representation of a full database model, and we can use that in a lot of ways. So we're going to start our entity data model with a database project. We can either start that from an existing project if we had one, or in this case, we'll create a new one. And this database project is SSDT's enhanced database project type. It's really a collection of SQL files that defines all of your database objects. And the system adds a reference from our application project down to this database project. So this enables a number of things. previously you've had these two worlds. You've had your entity data model world and you've had your database world, and they haven't really thought a whole lot about each other. So you've had a point-in-time representation of your database schema that you've built your entity data model from, and there have been a host of challenges when either of these evolve separately. So you've spent a lot of time resolving conflicts when you need to synchronize the two worlds, right? So with this new integration, we enable changes to propagate through the system incrementally, and we give you deep control over that so that we can reduce the time that you spend resolving those conflicts. So let's see how this works. We'll add our author entity to the entity data model. And an authors.sql file is added to our database project. So we can open that up side by side so that we can see this interaction. So now automatically we have an authors table behind that author entity. So let's add the name property to the author entity. And immediately that column is propagated down to the database project. So Adi, what other constructs do we need for our blog application?
Well, I'm building a blog, so I need an author object I can program against, which we already have. I also need a set of posts for my blog, and I'm thinking I want to allow guest authors to post to my blog too.
Okay. Let's start with the post entity. We'll add that again through the entity data model. And again, we have a posts table that's automatically created for us, and we can open that up as well. So we need maybe a date created for that post. And as you would expect, that change is propagated directly down to our table. A column is created for us. And we want that date created property to have a data type date time. So let's go ahead and change that in the property window. Now this is an update to an existing object, and that again can propagate directly down to that column. So we're staying in sync as we make these changes. Now, so far we've only made changes to our entity data model and seen those changes flow down to our database project. Let's go the other way. So let's add our title column directly in the table. And that title property appears in our entity. As you would expect, you would also be able to do this directly through T-SQL. So SSDT's table designer there on the right has both that visual design pane and the T-SQL down below. So we can add a tag column directly in the T-SQL depending on how you like to work. And that will not only, of course, stay in sync within the table designer, but create that property. Thanks. All right. So we want to kind of link authors and posts. So let's add an association. We'll call that authors posts. And we want each author to be able to have many posts. Of course, we also want to have each post to be able to have co-authors, so many authors. So we have a many-to-many association. Now, a many-to-many association, as you know, is a concept that makes sense in your entity data model that is structured a little bit differently in the database. So the system has to be intelligent about how it adjusts your database project to enforce your many-to-many association. So if we look again in Solution Explorer, we have an authors posts.sql file. We'll open that up, and this is the join table that the system created for us with the foreign key constraints you need to enforce that association. And if we click on the many-to-many association in the entity designer on the left, we can bring up the mapping details window and make sure that that many-to-many association is mapped correctly to my join table in my database project. Great. Okay, so the other thing you said we needed is a guest author type. So let's add that also through the entity designer. And old news by now, the table is created. Let's open that up side by side. So guest author is really just a type of author, right? So we want guest author to derive from the author type. So let's add inheritance. And again, this is something that the system needs to be intelligent about how it reflects this down in your database project. So that foreign key constraint is created for us. It also auto-maps the necessary properties. So that ID column in your guest author table is mapped to the ID column in our base author type. So this means we have a redundant ID property in our guest author type in the Entity Designer. So we're free to remove that, but this is the first change we're going to make that we only want to make in our entity data model. So far, every change we've made, we want directly mirrored across the two. But we want to remove the ID property and not remove the ID column. So you've seen how we can keep these completely in sync, but it's equally as important to allow you control over how we do that. We're not going to enforce it. So we do this by something called the sync settings in the Entity Designer. Now, this UI is under construction as we speak back in Redmond, but we can walk through the settings right now. So this first tab is giving you control over what happens when you make changes in your entity data model, how and when those are propagated down to your database project. So the first setting you see here is for when you create entities or properties, does that automatically create a table or column in your database project? Right now that's set to always, and you've been seeing that when we do that, it just automatically creates a table. The second setting there is for deletes. So we haven't done this yet, and it's set to ask me. So whether you want to be a little bit more conservative about deleting things or you just want to manage that on a change-by-change basis, you can set this setting to prompt you each time you make a delete. So we'll see that when we delete our redundant ID property. The other setting I want to call out here is for renames. It's also set to ask me. Renaming is a common customization that you want to make in your application model so that that name is more application specific than maybe the generic database column name. All right, so let's see what happens when we delete the ID property from guest author. We're prompted, would you like to propagate the deletion of ID to the database project? Again, we don't want to, because that ID column we have correctly mapped in the inheritance strategy, so we'll say no. So by default, inheritance is giving us a table per type strategy, auto-mapping the properties that we need, and then we're able to control the behavior between the two worlds as well. So let's add a URL property for guest authors so that we can link out to our guest authors' sites. Again, the column is created for us. But let's make this name more specific to our application. So we'll call this property blog link. But this is another example of something I want to do in my entity data model. This is a customization on my application model that I want to make. But let's leave the URL column in the database so that that can eventually make sense for other applications if we need it to. So we say no to that propagation dialog. And now if we check the mapping details, we can see that blog link is correctly mapped to that URL column. Okay, so it looks like we have our basic constructs that we can program against for our blog application. So let's clean up some windows and write some code.
All right, so my task is going to be pretty simple. All I'm going to do is just write out all the posts and any authors, if there are any. So the first thing I'll do is, if you're familiar with the Entity Framework, you'll know that the model that we've been building up has been actually generating code at the same time. So the first thing I'll do is set up a using statement to say I'm using the Entity Framework object context. And this defines the scope of changes that I'm about to make that will eventually get saved back to the database, or essentially queried to the database. So the first thing I'll do is create a variable to hold all of the posts that I'm going to pull in. And I can say I'm pulling in the posts from the object context. This is going to issue a query to the database. And I'll also include the set of authors for each post. So this is a feature in the Entity Framework known as eager loading, essentially for performance reasons, so that when we actually go and query for the authors for each post, we don't issue a second query. We're essentially pulling in the entire object graph here. And I'll project this to the object, the IEnumerable as well. So the next thing I need to do is check if there are any posts. And if there aren't any, then I'll write out a simple message. Now I'll for each over all the posts, write out its title, and then I'm going to for each over all the authors for each post. And here I can actually use inheritance to say, well, there's some authors that may be guest authors, so I'll define a variable here. I can check to see if this guest author is null. And if it is null, I'm just going to write out the name. If it isn't, then I'm going to write out the guest author's name again and their blog link. I'll add some formatting here to clean this up. It looks nicer on our output. And add a console read line. The thing to note here is that, of course, I could have saved off the name, but as we'll see later on, this is useful. It's a little hacky approach, but we'll see how we'll use it.
All right, so it looks like we're ready to run our application. I want to see this thing up and running. So we're just going to run our application. We've been working with this database project, so we haven't done any initial setup to target any database instance. So what's happening when we run this is because of that reference between the application project and our database project, we're able to build our database project, deploy that. Where is that deploying to? We're using a feature of SQL Server Denali called Local Database Runtime, which is an on-demand, file-based database instance that we can use tightly with our project system for debugging, to test with sample data. And since SSDT database project uses that automatically with no initial setup for your debug instance, we sync that connection up to our application. So we deploy our database project to local DB, as we call it, and then run our application against that. So we didn't add any data, so no posts added. Looks like our application at least is starting to work. So let's go add some data to local DB and make sure our application shows data. So I mentioned local DB is really a database instance that you're free to use how you want it. So we can get to it through Server Explorer. We see local DB here, and expanding that, we see our database project database that we just deployed. This SQL Server top-level node in Server Explorer is something that SSDT adds as your hub for your SQL Server development. So local DB will show up there. So there are a number of ways to add data. Let's right-click on our authors table. And there are a couple options here. So we can, of course, query against local DB just like any other instance. We can view the code on the authors table, which will give us the T-SQL definition of that table. We can view the designer, which will give you that table designer that you saw earlier. So let's view data so that we can add data directly into our local DB instance. So we have a data grid. We could type in here. You, of course, could run scripts. One of my personal favorites, you can copy and paste into here. So we can open up this Word document. We have a table, maybe a spec with some sample data. He's going to copy that table, Control-V into our data grid, and boom, we have some data. Awesome. Okay, so to save you some little time for our next three tables, we'll just run an insert script to insert the rest of our data into local DB. All right, so now we have some data. So let's F5 our application again. Again, this will build the database project, figure out if there are any differences to the schema, deploy those if there are any, and run our application against it. So as you can see, we have some data there to show in some blogs we've been writing. Okay, great. So as we've been developing our application and database together, you've been able to see that integration and how you can control the interaction. You've also been able to see local database runtime and how we can use that not only for the database project, but also for the application, so that when you hit F5, you're up and running really, really quickly. So far we've made changes in both the database project and the entity data model, but we've mostly been letting the entity data model drive our database schema. But now Adi has a few tasks that he needs to complete in our database project. So his boss wants him to add a mechanism to track the activity of our authors on the site. So how are we going to do that?
So in terms of activity, I guess you're talking about the number of total posts for an author. So if we were to do that completely in the database, then we definitely need a total post column in our authors table. We would need a stored procedure to essentially increment that total posts column given an author ID. And we would also need a trigger to call that stored procedure whenever a post is added.
Okay, sounds doable. Let's go for it. Okay, so let's start with the total posts column. So now we're in our database project again, open up our authors table, and we'll just add that total posts column through the table designer with a default of 0. And then we want to add our stored procedure. So again, through the database project, we'll add a new stored procedure. And this is just going to update total posts. So Adi's just going to type out the code for this simple stored procedure. And as he does that, notice he's going to get rich IntelliSense for his T-SQL in his database project. So one of the major goals of SSDT database services is to bring T-SQL up to the level of C# and VB in Visual Studio with first-class language services like IntelliSense. Super useful. Okay. So this is going to, for a given author ID, increment total posts. So the last thing we need is that trigger. So this trigger needs to be on our join table so that when a post is added for any given author, we execute our stored procedure. So again, SSDT's table designer has a pane on the right for all of the objects related to your table that you really need to know about as you're developing your table. So as you can see, indexes, foreign key constraints, those are all there for that particular table. And likewise, we can add a trigger here. So let's right-click and add new trigger. And as soon as we give this a name, we get kind of a SQL stub that you can start working with for your trigger. We've written up one beforehand, so we're just going to drag that in from the toolbox. And this will just execute our stored procedure when a post is inserted into the database. Great. So the last thing, while we're looking at our database project, I'm thinking that a lot of people kind of have an alter ego for their online presence, depending what you write about in your blogs. So maybe we want to change that name in author to username.
Wow, really, Sarah? I just wrote all this application code,
I know.
and you're making me change name to username in all of my application code.
That would suck.
That's great. Thanks.
Well, let's just see how often we use name.
All right.
So in the authors table where name is defined, let's find all references. Actually, we should probably open the editing designer.
Right, so this is where I have name, so I'm highly doubtful this will work, but...
I don't know. I don't think it'll be that bad.
Okay.
So let's find all references on the name column. So not only with SSDT's database services is this giving us find all references for T-SQL, but because of that reference in our application project, the system has the knowledge of the entire stack and is giving us the references in our C# code as well. So that first line you see there is where name is defined, of course, in our table definition SQL file. The second is the file where our generated code from our entity data model sits. Of course, that has name there. And the last two are, of course, where Adi used name in his application code. So it looks like maybe we can make that change through the entire system. So back where name is defined, let's try refactor rename on the name column. If we could take questions at the end, that would be awesome. Sorry, thank you. Okay, so name to username. And you get the refactor dialog that you're so familiar with in Visual Studio. But not only do you get refactor rename through your entire database project, any SQL references to the name column, but you also get to preview the changes to the references to name in your C# application code. So it looks like we can make that change. Let's apply it. And do you want to check that I was right about that?
Let's see.
Sorry.
All right, so I see the name got renamed to username in my conceptual model, which is great. Another thing I noticed was that when we added the update total post stored procedure, it actually got pulled into my model with the correct parameter information, which is great. Another thing is that it also created a function import in my conceptual model. So a function import is essentially a way in my application code that I can call a stored procedure. And what's happening behind the scenes is that we're looking at the stored procedure query, the script fragment, and we're determining the result, the shape of the result set to actually pull that through the function import's return type. So there are two key points to take away here. One is that you're able to essentially control this switch, so you can edit this function import after we've gone in and made those and inferred the changes. You can keep that only in your conceptual model. And you can also control whether or not the stored procedure is actually pulled into the model through the sync settings that we demonstrated earlier.
Awesome. Okay. So since we used refactoring, we have that information in a refactor log in the database project. So when we F5 our solution again, it will again build our database project, deploy any changes, but since we have that information in the refactor log, it will issue the SP rename, and our data, unfortunately, is preserved for you to see. So T-SQL refactoring not only through your database project, but with that reference cross-language refactoring. Okay, so this application is getting fairly complete. We've been able to see the T-SQL language, first-class language services with IntelliSense and refactoring, go to definition, find all references. We've been able to see cross-language refactoring between your projects. And we've also been able to see stored procedure sensing and that function import inferred into your project. Okay, so at this point, we're moving towards our final steps of development for our application and our database. And Adi wants to finish developing his application without affecting the database project anymore. So we're going to take our database project and hand it off to the real database experts, the database developers down the hall. And we need to finish our application without that database project. So let's see how we do this. Oh, and we also want to debug. And then I mentioned in the beginning we need to get this up and running against SQL Azure. So we're going to use a feature of SSTT database services called SQLX Snapshot. I briefly mentioned this when we had the option to create the entity data model from a database model. And that's what this SQLX is. So you can think of it very similar to a DLL. So just like you can reference an assembly instead of a project, we're able to reference a SQLX file instead of a database project. So we can create this from the database project. We right-click and snapshot project. And this gives us a .SQLX file. And this is useful just in the database development world in a number of ways. So as you can see by the default name we give this, it's really just a point-in-time representation of this version of your schema. And you can create this from a database project. You can also create it from a live database. So it's really useful for keeping track of versions of your schema. So before we move on with this SQLX, we want to publish our database project to a test server that Adi has to run his application against before he can tell his boss he's done. So we're going to use publish from the project. So Adi's just going to put in his test database connection information, and we'll kick off this publish. So database publishing is designed to support the multiple environments that you work with. So you can take the same database project, and you can publish it out to a test environment, you can publish it out to a dev environment, you can always generate the script that would be executed to either verify or save that off. So now we can go to Server Explorer, and we have this test database deployed. Let's quickly add our sample test data in there by just executing a quick script. And we're going to want to be able to run our application against this test database. So the SQLX file is also useful to the application developer in a number of ways. So we've been working with our entity data model with this reference to the database project, and that's been flowing changes between the two. But I mentioned now that we want to finish our application without affecting the database project. We already handed it off. We no longer have access to it. Our database developer tells us not to touch it. So now we need to re-reference our entity data model to our SQLX file. So we can do this through the property window. We have a property called storage reference. And instead of the database project, we'll browse for that new SQLX that we just produced from the project. So this is similar, like I said, to changing the reference to a DLL. So we slide in this new database backend underneath our entity data model. Now in Solution Explorer, we can actually completely remove the database project from our solution. So if you notice, the database snapshots folder in the application project now contains a copy of that SQLX, and we're now completely self-contained in our application project. We have both the database model and the entity data model, and they can still, build off of each other. Well, the entity data model can still build off of the SQLX model. And as you can see, some of the constructs that we added, like the total post column, show up. This is a full database model that we've been developing. But also, the customizations that we made in our entity data model are also preserved. So we had renamed that blog link property in our entity data model, and that was a customization we made just in our application that we did not flow down to our database project. And so if we check the mapping details on this, that change is preserved. So blog link still maps correctly to the URL column in the schema. So you can imagine some useful examples of using that SQLX. Number one, simply for versioning for your databases. Imagine if you shipped a V1 of a database out to a customer. You no longer have direct access to that database, but you can keep versions of what you gave them as SQLX files. Also, for team development, this enables a really efficient scenario that we're going to see here, where you have a database development person or team who owns the database schema, and then you have your application developers who need a version of that schema to build from. And not only can you pick up the new version of that schema as a SQLX, and it will give you the new constructs that have been added, but the way we've done this, it also allows you to preserve the work you've done in your application. So sliding in that new database version will not overwrite anything you've done in your application model. All right. So next thing we want to do is debug our application. So what we want to test to make sure it works is that trigger we added. So we want to make sure that when we insert a post, the trigger executes our stored procedure correctly. So let's go into our program code, and we're just going to add some code that will manually add a post instance so that we can test through this little tracking mechanism that we added.
Okay, so as Sarah said, I'll just add a new post, and I'll give it an ID and a title. I also need to add this instance of a post to my object context. And a post has a set of authors, so I'll just set the only author of the post to the first author in the object context. And finally, I'll save all these changes back into the database, which will actually send an update query, insert query, actually into the database.
Okay. So in order to debug this, the save changes is really where that post is inserted into the database, right? So we want to set a breakpoint there. But what we want to know is, do we get into that stored procedure? So let's go to our database in Server Explorer. We're in our test database that we've deployed and added data to. We can navigate all the way down to our stored procedure, right-click and view code. And this gives us the T-SQL definition of that object directly from our live database. So we want to see if we get in here So let's set a breakpoint inside the stored procedure. Okay, so just to reflect for a second, we have a breakpoint in our C# application code and a breakpoint directly in our database object. So we're going to run with debugging.
Just to make sure all the stars align, application debugging is on for our database. So
we hit the breakpoint in our C# application code, and if Adi hits F10, it didn't work. That was a little anticlimactic. But so there are a few options that need to be set. So we need to have SQL debugging on. We need to have application debugging on.
Stars didn't align, so, right.
That is, of course, oh, it is on. Should we try it again?
Sure, why not?
All right, let's try it again. Second time's the charm.
Oh, we didn't change our application configuration file.
Oh, we're not even targeting the test database. That's awesome.
Right.
Okay, so let's go to app.config, and we're still targeting that local DB instance. Oops. Okay, so we put in that test database connection information, and this time, when we run with debugging, we hit our breakpoint in our program.cs file. You get the full debugging experience you would expect in Visual Studio, and now we will step through, and we hit the breakpoint directly in the stored procedure in our database. Awesome. Okay, so of course the full debugging experience, locals window, you have your call stack, so you can see the T-SQL that inserted that post into the database. You can see that the trigger was triggered, and you can see that the stored procedure was executed. Awesome. Okay, so debugging from our application directly into our database, that succeeded. And our last task is to get this entire system up and running against SQL Azure. Adi, do you think we're going to be able to do this before your boss leaves?
We've done a lot of stuff in the past 40 minutes, so
true.
It's looking good.
All right, good. So in order to get this up and running against SQL Azure, we first need to take the database, of course, and put it in the cloud. So I mentioned that we had handed off the ownership of the schema over to our database experts, and our database developer has been busy making some schema changes down in his office. So let's channel our database developer for a minute and see what he's been up to and how he's going to take this database to the cloud. God, I keep doing that. It's the unicorns for the Entity Framework team. See you guys in the back.
Shout out.
All right. So we're here with SSDT in Visual Studio again, but this time we only have that database project in Solution Explorer. And now we're the database developer. So he needs to take this database to SQL Azure. He's made a few schema changes that we're going to have to go pick up in our application again. But first, he's done with his schema changes. He's going to take another snapshot. So this is, of course, another version of the schema. He's evolved it a little bit. We snapshot the project. So now we have two versions at different points in time of our database schema. One of the really useful ways to use these SQLX files is in schema compare. So you can compare a SQLX file, again, it's just a database model, to any other database project, or to any other SQLX file. So we're going to compare the SQLX file that we took earlier and the SQLX snapshot that we took just now and see what the database developer has done in the meantime. So it looks like he's added a categories table, and it looks like he's changed our posts table a little bit. So you can see the code diff there tells you that he's added a foreign key constraint to the categories table, and he's added a category ID foreign key column, of course, that replaces this tag column that we had before. So he's added a better mechanism for us to categorize our posts. That's great. So now he's going to take this project to the cloud. So one of the really useful things about SSDT's database project type is that you have a single project type that you can target to different versions of SQL Server. So if we go into the properties of our database project, And it's by default, we've created a Denali targeting project, but let's drop this down. You can see the versions that we support here. So we're going to set this to SQL Azure. As soon as I do this, the tool is running SQL Azure engine validation through our database project. So before we even try to go publish our project to SQL Azure, we can be confident that we're not using anything that would violate some limitation that Azure has. So for example, if we go into a table file and try to make use of something that Azure doesn't support, we can see the type of errors, the addition-specific errors that we get. So if we hover over that, is small type, but it says that file group reference is not supported in SQL Azure. So you're getting addition-aware validation through your database project, and you can change that to target different SQL Server on-prem, SQL Azure, etc. Okay, so if we remove that and check our error list, if it's clear, we can be confident that we are Azure ready and we're ready to take this project to the cloud. So again, we will use publishing. And this time we're just going to load a publish profile and kick off that publish. So publish profiles are just a quick and easy way, if you frequently target the same database, you can just save off that connection information and publish settings, and it's just an XML file that you can load. So it's just a quick way to do that. And then we have this tool called the Database Activity Monitor that is your way of monitoring any long-running operations. So publishing, of course, especially to SQL Azure, can be a long-running operation, and you can monitor those steps as the system goes through them. You can also view any of the artifacts that it produces during that process. So as soon as the plan is done, you can view that. As soon as that publish script is done, you can view that. So it looks like it succeeded. The demo gods are being friendly now. So now we can go to Server Explorer and check that that database deployed to Azure. So there's our SQL Azure connection there at the bottom. And our database developer was a little bit smarter than us and added a post-deployment script in the project to insert the data instead of having to query the database to run that insert script. So data's already there. All right, so seems like we should be able to go back to our application now. The database developer comes down and knocks on Adi's office door and says, I've made some changes. You need to make your application work against them and run against SQL Azure. So we're back in our application. If we open up the Entity Designer, so now we have, the database developer has produced a new version of the schema. So we need to pick that version up. And we're going to do that by, again, re-referencing our EDMX to that new SQLX that the database developer produced. So we'll browse to the new file. And again, this is leaving behind that reference to the old schema version, picking up the new version of the schema. So you can see the category ID property was added for us for that new column. But it's also not overwriting any of those customizations that we've made to our application. So let's go to the model browser and see that the category entity was created since that categories table was added. So let's drag that onto our diagram and see where that sits in our model. Okay, so it looks like we can program against this. It has an association with our post entity. So let's go to our application code, and our application will now just show posts for the general category that the database developer has defined.
Right. So I can remove some of this code here, since we don't need it. And I'll just include a simple where clause.
Does that have to go after include?
Oh. Where the category name equals general. And add a dot. Oh, sorry.
That was good. All right. Looks like we're good. So the last thing, of course, that we need to do is, that we forgot last time, is target our application at our SQL Azure database. So through app.config again, Adi has that connection saved away. He's just going to copy and paste that in. And now we're ready to run our application against the database in the cloud. Let's see if this works. Let's run it. Awesome. Okay, we showed the most important post that we had. It's the only post the database developer wanted to show. It looks like our application is complete. Adi can call his boss and let him go to happy hour. Maybe he'll even buy him a drink. So as we've built up our application and database, we've seen a number of things that SSDT and this integration piece enables. So we've seen the integration with SSDT database services and how you can control when those changes propagate through your system. We've seen a new way of working with the SQLX snapshot. So not only can your database developers have a really lightweight and easy way to keep track of these versions, but the application developer has a really easy way to pick up new versions of the schema, code against them, and not lose any of that customized application work that he's been doing. We've also seen cross-language refactoring and debugging from your application straight through to your database objects. And we've seen, so importantly, that SSDT can make your teams more efficient, not only with this new way of working, but it also, of course, integrates with source control and team build and everything you would expect in the Visual Studio environment. We've also seen that with multi-targeting of this database project and addition-aware validation, how easy it is to develop for different versions of SQL Server, especially if you're moving to SQL Azure. So you can develop offline, make sure that your database project is ready to go to the cloud before you actually go ahead and try and do that. So bringing all of these tools into the Visual Studio development environment enables us to build off of SSDT's database services, give the system knowledge across the entire stack to enable a lot of those cross-project functionalities, and give you the most productive way to develop applications and databases together so that your application developers and your database developers will not spend so much time on the conflicts between their changes, and they can actually get along better and be best friends forever. So thank you very much. We ended a little bit quickly, but a couple other things I wanted to point out to you. There were some related sessions. This first one was specifically about SSDT's database services, and that was on Monday, but the video is available already, I think. We have a hands-on lab, and we have a demo station that Adi and I and a few team members will be at tomorrow as well. We also have a team site on MSDN for SSDT. We have a forum that we would love to hear you guys' feedback on. And we also have a blog that you'll be seeing a lot more activity on in the next few months. So SSDT, the first time it comes out publicly is this summer with Denali's next CTP. The integration piece will come soon after that. And a lot of that integration has not been seen before. We've announced it previously, but at very early stages. So a lot of that stuff is really, really new. And please feel free to email myself or Adi and tweet. That should be at SQLSDT. And this deck is on the TechEd website, so you can always have these resources. And please fill out session evaluation forms. We would greatly appreciate that. And at this point, we can take questions. Yeah, let's use the microphone so that the recording can hear you all as well. And thank you everyone for attending, by the way, before we do that. Thanks.
It's not on, is it? Oh, it is. Yep. The snapshots only preserve schema, not data?
At this point, yeah.
Is there going to be a better story for migrating data as well?
Yeah. Data, kind of our whole data story, is our next thing to go tackle. So we've heard a lot about the need for a good functionality around reference data. A lot of those things are kind of next on our list. Yep.
What you showed today was the basic CRUD operations. Do you think we can do any business rules in those entity models and when you insert, update, and all those kind of things?
So
You show the basic CRUD operations, right? Say if you are doing save, you want to do some business rules in one of the entities, how would you do that?
So currently the Entity Framework, Entity Framework 4.0 has a lot of good support for stored procedures. So if you need to run business rules, you can always define that in a stored procedure. And in terms of just the application validation, if that's what you're looking for, we're still working on some functionality around that.
So when you actually change the column name from to username, so it showed the tables and the views that got affected in the C# code. Would it do the same for like stored procedures and functions?
Yep. So you can refactor through the projects anywhere you can refactor basically.
So any database object.
Yeah, and we're working on going the other direction as well.
Your demos used a model-first approach. Is there support for code-first entity framework as well?
So that's something we're thinking about right now. They're sort of separate efforts right now. And as Code First gets out there, and as we hear how you guys are using it, we are definitely paying attention to that to see how this will fit in as well.
Another thing to mention there is, if you went to Jeff and David's talk on Code First 2 days ago, I think, they demoed a functionality called migrations. And migrations actually uses some of the Juneau functionality under the hood. So we're working very closely to make sure that some of these tool sets align and we get sort of cohesive functionality across code and XML.
Yeah, so one of the big under the hood things about SSDT database services is really our deployment engine, and so we can share that across these workflows as well.
I have two questions. The first question, in your demo, when you were doing your basic CRUD operations, it was using inline SQL. Can you inject stored procedures over the top of those so that all your CRUD goes through stored procedures?
Yes, actually, that was a similar question asked earlier. So the Entity Framework essentially allows you to map entities, your conceptual objects, to stored procedures for insert, updates, and deletes.
Okay. And then can you inject rules into the Entity Framework so that, like when you created your tables, it used just a basic ID. Can you inject other rules that would use different naming conventions if you had?
That's a great question, actually. So something we didn't really dig into with this demo was what's happening under the hood. And essentially, you can think of it as a configurations over conventions concept. So what we're doing is we're taking these sort of conventions that we've built, entity for a table, table for an entity, and those are defined sort of decoupled from the main translation engine under the hood. So eventually, we want to get to a point where we can actually allow users to plug in their own conventions, TPH, TPT, things like that.
Will that be part of the first CTP, or
that will not be part of the first CTP?
Okay.
Yeah, naming conventions is something we've heard a lot about. We want to add the ability for you to customize that, but also we didn't show like table per hierarchy mapping strategies for inheritance. That's another thing you can do in your entity data model by these configurations in the EDMX that Adi mentioned. So by default, we did table per type, but you can definitely do more complex things with the configurations.
Okay, thank you.
Thank you.
Are you going to do also the synchronization of a database project with the semantic models as well, or just the EDMX?
Another great question. So with Juneau, essentially what we've done is we've allowed the ability to build a model over a database at design time, right? And so what this project is really doing is synchronizing that model with the Entity Framework model. But as you mentioned, you can think of other semantic models out there, integration services, reporting services, analysis services, right, that we could sort of hook into and synchronize. So.
And second question, for the remote debugging on SQL Server, does it require any special type of permissions to be able to do that?
Go ahead. Well, in terms of the permissions, All I did at design time was basically just enable a few configuration options. Typically, when you're doing your debug loop, you're operating against local DB, the local DB runtime that Sarah mentioned, and you'll have all the permissions there that you would, essentially it's part of the database project, so you own that, and you have all the permissions necessary to create databases.
So there's kind of a few debugging loops. So the local DB, that's very closely integrated with the database project, that's really meant to have a good debugging loop. We wanted to show it directly into SQL Server, which of course is also enabled. But local DB is it's yours. It's used with your project. And I know that debugging through SQL Azure is a little bit of a different
But
story.
I thought you demo debugging on a separate instance of SQL Server, not the local host.
Right, yeah, we did, yeah. And I don't think that required any additional.
No.
Because basically what we do is we can just reverse engineer the definition of that object. We're not changing, anything.
Yeah. You did show the debugging of the store proc, right? If that store proc calls another store proc, so all the input parameters for the second store proc will show up the values in immediate window?
Yep.
Okay, thank you.
Here's a synchronization question, kind of similar to what I wanted to ask, but let's say that you already disconnected your SQL project, deleted it from your solution, but then you would like to continue making changes to the entity model and would like to still make it to the schema. So how do you do this? You just include back the SQL project, or?
Yep, so you can always bring that database project back in and just reference it again. And anything new that's been added there, you'll have the ability to light up in your entity data model. And then anything new that you do in the entity data model, again, can flow down to the database project. Something we also want to do in the future, so right now what we showed, the SQLX file is read-only once you create that. We are looking into the ability to work with the entity data model and actually be able to produce those SQLXs as well, but not something we have right now.
Not sure if this one already got answered, but back to the data question. While you're still using local DB and you've got data in your database and you add a column, is it drop and data's gone, or does it change the alter table, or what happens?
Yeah, so the system, you can always work declaratively with SSDT, and the system will figure out the right script to generate. So it'll figure out that alter table script for you, and so we won't drop your data, whether it's adding a column, a refactor, rename on a column, all those scenarios, we can be intelligent about that. And something actually having to do with that we didn't show, that's kind of more on the database development side, that they showed on Monday, is declarative online development. So when you're directly connected to your database, you can develop those object definitions as opposed to always having to figure out those alter scripts for yourself. And so you can develop declaratively, and so Adi mentioned that we build this database model in memory on top of either a database or a database project. So we can do the dependency analysis on that in-memory model, and so we can chase down dependencies while you're designing your database objects, even in the connected scenario. So the common example we show is dropping a column from a table. At design time, it'll let you know if there's like a view that depends on that or whatever. And then the alter script that the tool produces will figure all that out. So if it needs to deal with schema binding on the view, it'll do that and all that good stuff. Yep.
Did I understand you correctly when you said that SSDT will include what today we refer to as bids?
Yep.
Now, will that be in the CTP?
Yes. Pav, is that? Yep.
Okay. The reason I'm curious is today, if you want to design a SQL 2008 R2 report, you have to go to Visual Studio 2008 to do that. So that will be the opportunity when we can finally start using VS 2010 to design those reports.
Yep.
Great.
It'll all be on the 2010 shell.
Be a good summer.
Yep. Any other questions? Yep.
Yeah, in our organization, we have enterprise data that multiple applications are sharing. And aside from that, each of the applications has their own database as well. So is there a possibility for us to do multiple source of a database and do entities out of those? Because actually our entities are, the attributes of our entities are distributed in those different databases.
To have one entity data model that has multiple database schemas. We do not support that right now.
Yeah, we don't support that right now, but I would say that eventually you can imagine a world where you have one entity model, if you're looking at the Solution Explorer in Visual Studio, and you have several database projects that represent these sort of composite sort of parts of a total database essentially. So we eventually have to support that. So eventually we will address that scenario.
Yeah, thank you very much. And one last question is, do you have plans of having an automated way? Example, I have test data given to me by the business, and it's in Excel form, and I want to add that automatically to my post-deployment scripts. Do you have plans of having an engine of converting those automatically into insert scripts?
I don't think we have that on our backlog. That's good feedback, though, that you would need that.
Thank you very much.
Thank you.
Any plans to enhance the schema comparison utility to have some sort of useful export format other than scripts? It's one thing that, one limitation I think compared to Redgate toolset is that you can view it in this nice grid in Visual Studio, and that's great. But the only way you can export it to share it with other users is in a SQL script.
What kind of formats?
Maybe an Excel format with details of differences, or an HTML report or something like that.
Yeah.
A linked HTML report, if you've ever looked at like the Redgate utility, that's got some nice formats like that. Is that on backlog anywhere?
We've talked about that. I think there's some other things like the reference data kind of stuff that we want to go after first, but yeah, that's good feedback. Thanks. Anyone else? Questions? All right. Thank you very much.